This is brought to you by the Alumni Association of PISJ-ES.
Let's add some more fun to this example. Let's say we have the same crate. Okay? But now we are introducing some friction in this crate. Alright, so we are introducing some friction in this crate. The mass is 300 kilograms and we will be applying a force of 600 newtons. I am keeping this as, or let's say we'll be applying a force of 800 newtons. Let's apply a force of 800 newtons. Alright, so this would make sure that we are able to see it moving correctly. So I am taking a normal value, otherwise if I take like 50, 100 or something, it would just move too fast for us to watch. So now that we will be introducing some friction, and you will see what happens when we introduce some friction. Now just let me, okay, sorry, okay, this is worse. Here you go. Now I am switching on friction and you can see that the applied force I am applying is 800 newtons here. Let's see, first let's calculate what happens if there is no friction. With no friction, with friction is equals to 0. Let's calculate what happens when friction is equals to 0. When friction is equals to 0, the applied force is the only force in this direction. So F is equals to MA. Since this is a total force only, so 800 is equals to 300 times acceleration. The acceleration becomes 800 divided by 300. This is 2.67 meters per second square. This would be our acceleration. Now we are applying friction. Let's see what is our acceleration, because we don't know the value of friction as yet. So we'll have to first we'll find out friction in this case, but we'll need to know the acceleration for that. We can't just have two unknown variables. So we'll see what the acceleration is when there is friction. So there is friction here. Let's see what happens. There is your acceleration, and let's see what happens. Okay, it's not moving because the friction is too much to make it move. It's just balancing it. It's just balancing the applied force and it's not moving. Well, let's see. Let's change it to 900, a force of 900. Let's see whether it moves. And it's still not moving. Let's change it to, okay, I was wrong about this. Let's change it to, let's say 1100. Go. Well, it's still not moving. I mean, what's happening? Okay, let's see, a 1500, force of 1500. Well, yes, it is moving, but it's moving very slowly. It's moving with an acceleration of 0.4 meters per second square. So we have applied a force of 1500 newtons, and it's moving with an acceleration of 0.4 meters per second square. So if I just calculate, just change this 800 because we didn't apply 800, we applied 1500 newtons. So if I change it and just substitute 1500 everywhere, initially without friction, my answer would have been 5 meters per second square. If you just calculate 1500 divided by 300, you would find it, the answer would be 5 meters per second square. But now there is some friction, and the question says find the amount of friction when this is the acceleration. The acceleration when there was friction changed to be 0.4 meters per second square. Now let's see. We know that this is the same box. This is the same mass of 300 kilograms. This was our applied force, and friction always acts in the direction opposite to the motion, and the motion was in this direction. So the friction was here. Let's find out net force. Now, for now, I think you would be able to find out the net force directly without making the axis. Let's take this side positive and this side negative. So this would become plus F applied minus FR is equals to M times A. F net is equals to MA. Now, applied force was 1500, and we don't know the friction as yet, but we know the acceleration that it moved with, which was 0.4. So if you just calculate, this would become 1500 minus Fr. Is just calculate 300 times 0.4, and this would become 120. So let's just switch it here. 1500 minus 120 is equals to Fr, and Fr would become 1480 newtons. It was a huge frictional force. It was a 1480 newtons frictional force. So now, for a particular mass on a particular ground, the frictional force would be constant if it's moving, at your level at least. So we know the friction force, which is 1480, and we'll just check whether it's 1480 or not. We'll just check from here. Let's see, graph applied force. So this is the total force 1500, and the acceleration was 0.4 meters per second square. And sorry, not 1480, I'm sorry, I'm really sorry. This is 1500 minus 120, which makes it 1380. So friction force is 1380. Now this is what it tells you, 1378.8 newtons. So, and this minus sign tells you that it is in the opposite direction, towards the left of the applied force, and applied force is positive, right is positive, and left is negative. So this is what it tells you. Now let's see, if I take a force of 2000, if I take a force of 2000, let's see if the friction force stays the same. The friction force will be constant always. You can see from here, the friction force is still 1380. So for a particular mass, remember that for a particular mass on the same ground, once you find out the frictional force of a mass on a table, let's say, on that very table, okay, this is messed up, but on that very table, the same mass would always have, no matter what the applied force is, the same mass would have the same frictional force that you calculated from here. So you can use this frictional force in different cases, like we'll be doing right now. So now I am applying a force of 2000 newtons. This is my mass of, again, 300 kilograms. Let's see, I am applying first, I am applying a force of 2000 newtons. This is my force applied. And from the rule that I told you before, since it's moving on the same ground and it is the same mass, for a different mass or the same mass on a different ground, the friction force will change depending on the surface of the ground and the mass. But in this case, since it's the same mass and it's on the same ground, the frictional force would be the same, which was approximately 1380 newtons in this direction. So now let's find out the acceleration. The acceleration would simply be F is equals to ma by, so F here, F net is equals to ma. Now F net is the total of the forces. This is in this direction. Let's take the bigger one as positive, and this one, since it's in the opposite direction, this would be negative. So towards the right is positive and towards the left is negative. So this is totally my choice, but then I would have to comply with same rules throughout the equation. Mass times acceleration. The mass is 300. So this becomes 2000 minus, this becomes 620 is equals to mass is 300 times acceleration. The acceleration in this case would be 620 divided by 300. This would be 620 divided by 300, which gives me 2.067 meters per second square. Now let's see whether our answer is correct. So it's approximately 2.1 meters per second square. So 2.067 or 2.1 meters, approximately 2.1 meters per second square. Now, you know, we can also find the velocity from here. So the velocity would simply be the formula that we use is delta V over delta T is equals to, or T is equals to A. Let's find out the velocity for let's see, for 10 seconds. So this would become V minus U divided by T is equals to A. U is 0 because it's starting from rest, T is 10, and A is 2.1 meters per second square in that case. So it has rounded off the value. So V is equals to 2.1, which is the acceleration, times, this becomes 0, so this gets crossed off, times 10. So the velocity would be 21 meters per second at 10 seconds. Now let's find out. Let's just switch on the go button here, and we will see the velocity. Okay, here is the velocity. We will see what happens at 10 seconds. We'll pause it at 10 seconds. And here it is, yes. So it's about 20.6 meters per second, which would eventually become, if I just pause it here, 21 meters, and it's very close to our 21 meters per second. So we're using the same thing and it's working. So physics is working, guys. So you can also just go on this website on the link below, and you can play around with a little forces here and there. Just don't touch the controls that you don't know about, because you would just mess things up a little. So just don't touch them. Otherwise, you can just play around with this applet, and it's really amazing how they have worked it out. So just if you want to improve your concepts, I would recommend that you try that applet and click on the link below. So thanks for watching, guys. I hope your concepts are clear this time. We'll be coming up with more examples. Thanks for watching.